Hello everyone. Am I audible and visible both? Please confirm.
Hello everyone.
Yes. Yes, I am audible as well as visible. Okay, guys, once again, a wonderful good afternoon to all of you guys. And once more again, guys, have a wonderful class, guys. Today, I'm going to teach you all Kohlrausch law and its application. So, guys, once again, without delay, a very warm welcome to you all to your very own channel. Let's crack NEET UG in English. Myself Sharada Alok. I have been teaching chemistry at Resonance from past 10 years, guys. How you can get connected to us? Let me tell you. Go to Play Store, then download the Unacademy Learning app. Then click on to NEET UG and then go ahead for the subscription, guys. I just want to tell you that you'll be finding five type of subscription. The first one, guys, is plus subscription. The second one is iconic subscription. Let me tell you about both of them separately, guys. First of all, let us cover plus subscription, guys. Reena Gupta, hello beta, hi, how are you? Yes, how about your studies? Nice to see you guys. Come on. Under plus subscription, guys, you'll be getting top educators. Yes, will take your live classes, guys. So you'll be having daily live classes where you'll be, yes, taught by them. Not only that, you can chat with your educator, guys. You can chat with your educator, you can engage in discussion. You can ask all your doubts, answer in the poll. This polls is actually going to have questions related to the topic being taught on the screen, guys. Along with this, you'll be having live test and quizzes as well. They are actually going to evaluate your preparation with regular mock test and quizzes, and you'll be getting a proper detailed analysis of your performance after the quiz as well after the live test as well, guys. Come on, have a look at the screen. You will also get, guys, structured course which is properly precisely designed by the top educators, guys. Yes, all in line with your exam syllabus, which will help you best prepare for your exam, guys. Is that clear? Come on, guys. Is that clear? Mukesh Kumar Bomania is saying, hello ma'am, main aa gaya. Welcome to the class, Mukesh. Welcome to the class. So, guys, so not only that, you will be having one plus subscription. You will get access to all our live and recorded courses, which you can watch from the comfort of any of your device. Namaste, namaste, Arpita. How are you, dear? Yes, come on, tell me, how are you? All fine? Well done. Have a look at the screen now, guys. Okay. Is that clear, guys? Come on. The another subscription is all about iconic subscription, guys, which will definitely take your NEET UG preparation to the next level with personal coach. Yes, guys, you will get the top educators as your personal coach. You're going to get one-on-one guidance from them. Yes, guys, they are basically have actually trained many of the toppers so far. They are so examination expert, guys. You'll be taught by them, and they will act as your personal coach, guys. Come on, you'll be getting a proper preparation strategies as well. You'll be having an in-depth test analysis with personalized feedback, which is definitely going to improve your time management and exam approach as well, guys. You will be having a proper study planner which is going to ace your preparation with customized study plan and a bi-weekly reviews that will highlight your progress. So all by having one iconic subscription, you will be getting live classes from top educators, mock test and quizzes, structured batch course, very much in line with the exam syllabus, guys. Yes, so you must be wondering whether to go for plus subscription or the iconic one. I just want to tell you whatever you are going to get under plus subscription, you'll be getting under iconic one as well. Along with this, features like personal code, study planner, expert guidelines, and in-depth test analysis, guys. Is that clear? So let me tell you how much you have to pay if you want to go for iconic subscription, guys. For 6 months, you'll have to pay 38,000. For 12 months, you'll have to pay 65,000. For 2 years, you will have to pay 1 lakh. Okay, guys, just by having one iconic subscription, guys, and one more thing, guys, you will have to pay not this amount if you apply this referral code of mine. Okay, Mukesh is asking, ma'am, aap kaise ho? I'm very fine, dear. How about you? So, guys, needless to say that if you apply this referral code of mine, you will have to pay only 34,200 for 6 months, which is going to cost you only 5,700 per month. And for 12 months, you'll have to pay 58,000, which will cost you for a month around 4,875. And for 2 years, you will have to pay only 90,000, which is going to cost you 3,750. So, guys, if you apply this referral code of mine SA10, you will not only get this discounted prices, but also you will get so many other helps from my side, guys. Come on. But before that, before having those special help coming especially from my side, you'll have to apply this referral code of mine SA10, guys. Okay, is that clear? And one more thing, guys, 6 months, 12 months, 24 months, all these subscription are also available at no cost EMI. Now, guys, it is all about plus subscription. You can see there are so many options under plus subscription, whether you talk about 1 month, 3 months, 6 months, 12 months, and 24 months. Guys, for 1 month, you'll have to pay 7,000. For 3 months, you're supposed to pay 17,500. For 6 months, you'll have to pay 28,000. For 12 months, you'll have to pay 38,500. And for 2 years, you will have to pay 56,000. But again, needless to say, if you apply this referral code of mine, guys, you will get this 1 month subscription for 6,300 only, 3 month subscription for 15,750, 6 month subscription for 25,200, 12 month subscription for 34,650, 2 year subscription for 50,400. So don't forget to apply this SA10, guys. Okay, one more thing, the 6 month, 12 months and 24 months subscription are also available at no cost EMI. Okay, guys. And one of the interesting fact about this code, guys, this referral code, if you apply this referral code of mine, guys, trust me, not only the discounted prices you will be getting, but you will also get so many other help from my side. And remember, my target is to complete the syllabus for NEET 2021 by end of February 2021. I'm repeating, my target to complete the entire syllabus, whether you talk about physical chemistry or you talk about organic chemistry or you talk about inorganic chemistry. I will complete the entire syllabus of chemistry by the end of February 2021. Okay, guys, complete syllabus of NEET 2021. Your chemistry syllabus is going to end up by February, last week of February 2021. Very good afternoon, Ritik Bida. How about you and how about your studies going on? Come on, guys. Is that very clear to you all? Come on. Come on, if it is all clear to you, get ready to study Kohlrausch law and its application in another few seconds. But before that, take a pause and do share the video. Okay, guys, do share the link of the video to all your friends who are preparing for NEET 2021, 2022, and J-Mains or Advanced. It is going to help all of them, or to those who are in class 12. Sundar Chitra, good afternoon, ma'am. Very good afternoon, Sundar. How are you? And how about your studies going on, Sundar? Come on, share the link to all your friends who are in class 12, guys. Preparing for NEET 2021, board examination, planning for improvement in board examination, or simply preparing for KVPY. It is going to help all of them, guys. And all those who have not liked the video so far, do like, do share, and do subscribe the channel if you are watching this channel for the first time, or if you have not subscribed the channel so far, do so. If you have not pressed the bell icon so far, do so. Okay, is that clear to all of you, guys? Come on, come on. Have a look at the screen and ensure yourself that you're not getting disturbed by anything around you. Take a pen and copy. We are soon going to start the class. Come on, guys, have a look at the screen. We are going to study Kohlrausch law. Today we are going to study Kohlrausch law. But before that, guys, you need to study the conductivity of the solution of weak electrolyte as well as the strong electrolyte, and how it is affected by the concentration of the ion in the solution. And it is all done by Debye-Huckel on Sager equation. Repeated, Debye-Huckel on Sager equation. Guys, it is all related. It is all related. The conductivity is related with respect to concentration as per this equation given on the screen. What do we call this? We call it as Debye-Huckel on Sager equation. Guys, this is the conductivity at any concentration, and lambda naught is the conductivity at infinite dilution, guys, where the concentration is least. This is at any concentration. We can also represent it lambda to the power c, where this is going to represent the conductivity at any concentration, whereas lambda naught is conductivity at infinite dilution or the concentration is least. All clear, guys? Now this c is the concentration. Is that clear, guys? Now this is all related to the number of ions given by that. Actually the factor decided this the deciding factor whether it is, I mean, whether two electrolytes or mono positive or di positive type of electrolyte are there. It is all decided by them. It is all clear, guys? I mean, type of electrolyte, whether it is one type of electrolyte. Come on, guys. NaCl, then CaCl2, then MgSO4. Yes, if you talk about the type of electrolyte, they are NaCl is one type of electrolyte. CaCl2 is basically, yes, guys, 2 1, because the oxidation state of calcium, the charge on it is 2 plus. So it is 2 1 type of electrolyte, whereas MgSO4 is 2 2 type of electrolyte. This is actually, I mean to say, from type of electrolyte. I hope it is straight away gone over here. So they are the type of electrolyte is actually deciding this value. Is that clear, guys? This is actually decided by the type of electrolyte. Okay, guys, or kind of electrolyte you can say. Therefore, it is also represented as capital A. It is also represented as capital A. Is that clear? This is a constant, guys, also represented as capital A. The value is, and this is going to be a constant one. This is a constant one, guys. The value of A for a given solvent and a particular temperature depends on the type of electrolyte, okay, or the charges present on this. I've already covered that. The type of electrolyte, which I've just now explained you. If you talk about the type of, type of NaCl, it is 1 type. Whereas if you talk about calcium chloride, it is 2 type. Whereas if you talk about magnesium sulfate, it is 2 type of electrolyte. I hope it is straight away gone over here. And it is very clear from here, guys. Come on, what is going to happen for the relationship between lambda c and concentration, guys, with this equation? Can you tell me, guys? More the value of concentration, more a root c value, more will be this total value will be there. Will it be or not? Yes, it will be. Or you can say more concentration is there, that means lambda c has to be lesser, and less concentration of C will be there, means the product as a whole will be less, or higher will be the lambda C, or higher will be the molar conductivity. Is that clear? Are you getting it straight here? Well done. Well done, guys. Come on, have a look at the screen. If you talk about strong electrolyte, that is KCl, or weak electrolyte, that is acetic acid, guys, it is very clear from here. If you plot the graph lambda C with respect to square root of C, if this molar conductivity with respect to square root of C, that is concentration, is plotted, guys, we will find that, as concentration increases, there is a sharp decrease in molar conductivity of the strong electrolyte. Whereas that of the weak electrolyte, the decrease is very slight decrease, and it is not at all sharper as well. But guys, what is happening at infinite dilution? What do you mean by infinite dilution, guys? Infinite dilution means when the value of C decreases to almost not zero, but yes, near to zero, little bit positive. Yes, it should be more than, slightly more than zero. You can say when the solution is extremely dilute or infinite dilution, you can also call it, or the concentration is too less, you can also call it that way. In that case, what is happening, guys? Weak electrolyte as well as the strong electrolyte are behaving in the same way. And just see, this is the molar conductivity at infinite dilution, which is almost same for strong electrolyte as well as for weak electrolyte. So we can say that the weak electrolyte behave as strong electrolyte at infinite dilution. I'm repeating. Using this equation, we can see that at infinite dilution, even the weak electrolyte behaves as strong electrolyte. Okay, okay. So you can say whatever the concentration of the salt dissolved in solution, whether you talk about a strong electrolyte or you talk about a weak electrolyte, at infinite dilution, it is equal to sum of conductivity of the individual ion, or you can say the individual ion are cooperating totally towards the total conductance of the solution at infinite dilution. This is actually the Kohlrausch law. Is that clear? So how come Debye-Huckel-Onsager equation actually or finally relates to Kohlrausch law at infinite dilution? Is clear to you or not, guys? If it is clear, come on. If you have not liked the video so far, do so. If you have not shared the video to all your friends who are preparing for NEET 2021, or simply board examination or KVPY, do share the link to them. Also share the link to those who are preparing for JEE Mains or Advanced, because Kohlrausch law and its application are truly, truly very, very important to all of them, guys. Okay, and all those who have not subscribed the channel so far, do so. If you have not pressed the bell icon so far, do so, guys. Come on, have a look at the definition of Kohlrausch law. Guys, it states that the equivalent conductivity of an electrolyte at infinite dilution, I'm repeating, Kohlrausch law states that the equivalent conductivity of an electrolyte at infinite dilution is equal to sum of the conductance of anion and cation. Because at infinite dilution, whatever concentration of electrolyte is dissolved, whatever moles of electrolyte is dissolved, whether it is weak, okay, guys, how weak, no matter, but it is totally dissociated, same to that of a strong electrolyte, and therefore the conductivity at infinite dilution is actually the sum of conductivity of the individual ions. Is that clear? Is that clear, guys? This is all about Kohlrausch law, and it is very, very clear from Debye-Huckel on Sager equation just now we had seen. Guys, lambda conductivity at any concentration is equal to at infinite concentration minus a square root C. This is not true actually. Let me use an eraser. This is basically what, guys? This is C. So it is very, very clear that when this reaches to, guys, when this reaches to very, very less value, these two are going to be equal, guys. When this reaches to near zero, this two are going to be same. Is it, guys? Is it? So whatever the conductivity is there is measured will be actually the conductivity at infinite dilution. All clear, guys? Now guys, if you plot the graph between conductance with respect to concentration, we had just now seen that the slope is negative. What is the slope, guys? These type of questions are asked. So please jot down all this thing. What is the nature of a graph when conductance or at any concentration is plotted with respect to concentration? What is actually the nature? The graph is negative, guys. Okay, because the slope is what? The slope is actually negative. This minus a is the slope, guys. What is the slope? Slope is minus a, remember. Okay, is that clear? So all these, this every slide is very, very important. If you talk the importance of Kohlrausch law and the weightage of Kohlrausch law, if you consider NEET or JEE Mains or board examination, guys, come on, be very alert. All your eyes on the screen. Yes. Is that clear, guys? Come on, have a look at the screen. Okay. Okay, guys. Now it is very, very clear from here that lambda A and lambda C are known as ionic conductance of anion and cation at infinite dilution respectively. All done? Clear hai? Kohlrausch law is clear, guys. Come on, let us go ahead now. What are the application of Kohlrausch law? Let us cover it one by one. Guys, the first application of Kohlrausch law is to what? Yes, determine the molar conductivity of a weak electrolyte at infinite dilution. First application is, yes, guys, molar conductivity of a weak electrolyte at infinite dilution. Is that clear? Using molar conductivity at infinite dilution of strong electrolyte. Is that clear? Because it dissociate completely. Is that clear, guys? As weak electrolyte do not dissociate completely, so the conductivity cannot be directly calculated as it is being calculated directly in case of strong electrolyte. Therefore, using the molar conductivity of strong electrolyte, we use to calculate molar conductivity of weak electrolyte, and this is one of the common application of Kohlrausch law. Is that clear? Now, guys, the second application. Actually, second application and third application are related to each other, guys. Second and third, what's that? Guys, second application is to calculate alpha. And if alpha is calculated, we can automatically calculate Ka. That is, degree of dissociation is calculated. We can calculate dissociation constant. Isn't it, guys? Isn't it? Is this clear? Come on. Come on, we are going to cover this one by one. Don't worry. Now, guys, the fourth application and fifth application are related to each other. The same way 2 and 3 application are related, 4 and 5 are related, because if alpha is calculated, we can easily calculate Ka using the proper formula C alpha square, isn't it? Similarly, the fourth and fifth application are related to each other, because fourth application of Kohlrausch law is to determine the solubility. Guys, if solubility is determined, we can straight away calculate solubility product. Is that clear? If solubility is determined, we can calculate the solubility product. So I am counting once more all the 5 applications of Kohlrausch law. The first one is to determine molar conductivity of weak electrolyte, which otherwise is not calculated directly. Is that clear? Second and third are related to each other, because second application of Kohlrausch law is to calculate degree of dissociation, and once the degree of dissociation is calculated, we can also calculate dissociation constant. All done. Now, guys, the fourth and fifth application are again related to each other, because fourth application of Kohlrausch law is to calculate solubility. Done. And if solubility is calculated, we can also calculate what? KSP, that is solubility product. All clear? So all these are the 5 application of Kohlrausch law. All done? Done, guys? Let us look at them one by one. Guys, the first one is determination of molar conductivity at infinite dilution of any weak electrolyte. Okay, guys, is that clear? Now how we can do this with using strong electrolyte? Guys, take an example of acetic acid. We know that acetic acid, CH3, COOH. Guys, this is a weak acid. Done. But if we know the molar conductivity of, yes, acetate ion at infinite dilution, and if we know the conductivity of H plus ion at infinite dilution, guys, simply adding them, we are going to calculate the molar conductivity of acetic acid at infinite dilution. Is this clear or not, guys? I'm repeating once again what we have to do, guys. what we have to do? Simply, if you know any like individual ion, if you know any individual ion of weak electrolyte, what you do? Simply add the conductivity of individual ionic electrolyte of constituting the weak electrolyte. Simply add them with respect to the stoichiometric over there in the formula. Simply add them, you're going to get molar conductivity of that weak electrolyte. So in this case, how to know that acetate or H plus individually, it is again not possible, but yes, we can calculate molar conductivity of what, guys? Yes, sodium acetate, which is a strong electrolyte. We also can calculate molar conductivity of H plus. Is that clear? Is that clear, guys? Is that clear? We can also calculate this now. Now, what you have to do, simply add on this and subtract the molar conductivity of infinite dilution of NaCl. Done. So, what will done? What is actually happening here, guys? Molar conductivity of acetate ion can also be separately written as the sum of molar conductivity of acetate ion and that of Na plus ion. Is that clear? And this also can be written as H plus Cl minus, all done. This can be written as this minus Cl minus, all clear, guys? What you have to do, simply cancel molar conductivity of chlorine. Hello Hussein, how are you, beta? Welcome back to the class. How are you all, guys? Okay, and simply cancel the molar conductivity of sodium ion. Hello beta. Yes Hussein, I'm watching you beta. Hello, how are you? And how about your study, Hussein G? And what's your name, dear? Shall I call you Hussein, or you're going to share your name as well, the first name? Is that clear? Now guys, now everything on adding this and subtracting NaCl. Welcome Hussein beta. We are going to get some of molar conductivity of these two ion. We are sorry by beta, Diwali days, so many crackers are, yes, Diwali days, so many crackers bound to have in the vicinity. Hussain Sahab is saying, ma'am, I have 318 need. Okay, that's really great, beta. Okay, congratulations. Come on, guys. So the sum of these two will be actually obtained by subtracting the molar conductivity of NaCl at infinite dilution from the sum of molar conductivity of sodium acetate and that of HCl at infinite dilution. Is that clear? Well done. Well done, Hussein. Is that clear? Come on, guys. Is it clear? पक्का है समझ में आ रहा है so simple. This is the first application of Kohlrausch law. Okay guys, if it is clear to all of you, those who are watching, do like the video, do share the video to all your friends, come on, who are in class 12 preparing for NEET 2021 JEE mains advance, or simply looking for board examination or improvement or KVPY. Come on guys. Now let's have a look at the another application. Well done Hussein, all you guys, well done. Come on. Another application of Kohlrausch law is to determine the degree of ionization of a weak electrolyte. How do we represent, guys, the degree of dissociation or degree of ionization of a weak electrolyte? Simply by the symbol alpha. Done. Done, guys. Now, how can we use to do this? Guys, if you look at the definition of alpha, alpha is degree of dissociation. Okay, Hushan, well done, beta. Toyab. Okay, that's Toyab. Toyab, welcome to the class. How are you, Toyab? So, alpha is what, guys? Degree of dissociation. Alpha is degree of dissociation means what? How it is related to the number of moles dissociated upon total number of moles? Yes, it is directly proportional to number of moles dissociated upon total number of moles taken. All done guys. Now guys, total number of moles and conductivity at infinite dilution are related directly proportional. How come? total number of moles at infinite dilution, just now we had seen that, are completely ionized. All moles of the electrolyte, whether it is weak electrolyte or strong electrolyte, are completely ionized at infinite dilution. Is that clear? So can we say that at infinite dilution, what is happening to total number of moles, guys? At infinite dilution, whatever the total number of moles are completely ionized. So conductivity at infinite dilution is actually directly proportional to total number of moles initially taken. So can we write it as lambda m infinite dilution? Now, number of mole dissociated at a, like, will depend on the concentration at any uh, molar conductivity at any concentration, because that is not completely ionized at any given concentration. All the ions or are never ionized completely. Why they are not ionized completely? Because at higher concentration, beta, see, why at any concentration we take that all the moles are not ionized? There is a reason for that. What's that? At higher concentration, guys, at higher concentration, there is a greater inter-ionic, there is a greater inter-ionic attraction which retard, the motion of ion. Is that clear? Or we can say, guys, at higher concentration, the conductance of the solution decrease, or molar conductance decrease. Is that clear? Or, guys, this is directly proportional to molar conductivity at any concentration. Come on. So can we write this? The entire relation, guys, as alpha is also directly proportional to this. Can we relate this with alpha? Yes, we can. So, guys, if you have what? If you have molar conductivity at any concentration and also molar conductivity at infinite dilution, the ratio of the two is going to give you the value of alpha. Is that clear? Is that clear, guys? Now, one more thing, guys. Not only, guys, molar conductivity. If you know the equivalent conductivity at any concentration and equivalent conductivity at infinite dilution, then also, guys, you can calculate alpha. Done. And once alpha is calculated, guys, Ka, dissociation constant of the acid, is related to alpha by this formula. See, concentration of the solution, which will be always given in the solution. Alpha is degree of dissociation. Just by putting the value in this particular formula, you're going to calculate the degree of dissociation. Is that clear? Come on, if it is clear, all those who are watching, if you have not liked the video so far, do so. If you have not shared the video so far, do so. So, guys, it is very, very clear from here that alpha is related to molar conductivity or equivalent conductivity at any concentration and also at infinite dilution by this relation. And if molar or equivalent conductivity at infinite dilution or at any concentration is known, alpha can be calculated. Or out of the three, if any two are known, the third one can be calculated. All clear, guys? Is this clear or not? Don't worry, we are going to solve numericals as well. Don't worry, guys. Come on. If you have not liked the video so far, do so. If you have not shared the video so far, do so, guys. Come on. Come on, guys. The fourth and fifth application, as I told you initially, are also related. And let us see how they are related. Come on, guys. The fourth application is determination of solubility of a sparingly soluble salt. What do you mean by sparingly soluble salt? Sparingly soluble salt means, guys, slightly soluble salt. Than slightly soluble salt. Yes, Hussein, is it clear, beta? All those who are watching, it is clear. Do reply in the chat box and be ready for the numericals we are going to soon solve. Okay, guys, come on. So, what all salts are slightly soluble, sparingly soluble, guys? EgCl, silver salt, barium sulfate, lead sulfate, and mostly those which get precipitated when they are formed come under this category, guys. Okay, is that clear? Which dissolve to, why do we call them as sparingly soluble salt? Because they dissolve to a very small extent in water and are called sparingly soluble salt. As they dissolve very little, even a saturated solution of such a salt can be assumed to be at infinite dilution. Then molar conductivity of a sparingly soluble salt at infinite dilution can be obtained from the relationship, guys. Molar conductivity at infinite dilution is related to, yes guys, conductivity of solution and molarity by this formula, K into 1000 upon molarity. Yes guys, molar conductivity. Similarly, we can calculate what, guys? Molarity can be related to solubility. Why guys? Molarity and solubility are related to each other. Can you tell me? Solubility of what? Solubility of sparingly soluble salt. Remember, this is solubility of sparingly soluble salt. All done, guys. All done. Let me take a yellow pen now. Come on. Is that clear? Is it clear, guys? Solubility of a sparingly soluble salt is related to molarity with this formula. All done. Is this clear? Come on, have a look at the screen. Actually, sparingly soluble salt, guys, where the solubility is very, very less. Can we say solubility is very, very less? And we are relating this to Kohlrausch law. At infinite dilution, guys, can we say at infinite dilution, molarity and solubility are almost same? Can we say molarity and solubility at infinite dilution, guys? They are almost same. Same at infinite dilution. Done, guys. So this is what the application of Kohlrausch law, isn't it? So, guys, instead of molarity, we can replace this with solubility. And if solubility is calculated, we also can calculate KSP, guys. Come on, is this clear? Knowing molar conductivity at infinite dilution, conductivity of the solution, solubility can be calculated. All done, guys. All done. Now guys, if solubility can be calculated, KSP value can also be calculated very easily. For example, if you talk about AgCl, guys, AgCl, its KSP is equal to solubility square, and once the solubility is known, guys, square of that will give the KSP. Is that clear? Done. Is this clear, guys? Come on, if it is clear, do like the video and do share the video as well. So all 5 application of Kohlrausch law are done. Get ready to solve the numericals. Okay, guys, let us relist them again. The first application of Kohlrausch law is to find the molar conductivity of a weak electrolyte at infinite dilution can be calculated. The second application is to find out the degree of dissociation using molar conductivity at any concentration and molar conductivity at infinite dilution. If alpha is known, Ka can easily be calculated. Fourth application is solubility, and if solubility is known, Ksp can be calculated. So this is how all 5 applications of Kohlrausch law is done. Come on, guys, have a look at the very first question of it. Come on, by the time I'm solving the question on the screen, guys, you all guys do one thing. What you have to do? Do solve this question and reply the answer in the chat box out of A, B, C, which is the correct answer. Waiting for your answer, guys. By the time I'm having a sip of water, you all guys please solve that question. Okay, guys, let us solve this. Come on. I hope all of you are, those who are watching, are also trying this question. So let us first of all, guys, the very first step is to jot down the things which are given in the question. Then automatically you'll find that the formula which is to be applied over there will automatically click to your brain. Okay, guys, come on. Have a look here. Ionization constant of a weak electrolyte, guys. This is what is given, guys. Ka is given. Ionization constant or dissociation constant are same. Ka is given, while the equivalent conductance of its 0.01 molar. What is this value? This is C. This is C, guys. Equivalent conductance. C, this is C, guys. This is equivalent conductance. Equivalent conductance is this one. All clear, guys. This is equivalent conductance at the particular concentration C. Can we calculate equivalent conductance of electrolyte at infinite dilution? Come on, can we calculate? Come on, let us see how to calculate this, guys. Ka is given, okay, C is given, lambda MC is also given. We have to find out, guys, lambda M infinity. All clear? Yes, is that clear? Yes, guys, Ka, let me change the color of the pen. Ka is equal to C alpha square. All clear, guys? All clear? Ka is done. K is given. K upon C. Square root of this is going to give you alpha. All clear, guys? This will give you alpha. Done. Alpha. Is that clear, guys? This will give you alpha. All done. And once alpha is calculated, just now we had seen alpha is related to molar conductivity at any concentration and molar conductivity at infinite dilution with this formula, guys. We can directly relate the two, isn't it, guys? So what is the value of K? K is 25 into 10 raised to the power minus 6 upon C is, yes guys, C is zero point zero 0.01. Square root of it will be equal to 19.6 upon molar conductivity at infinite dilution. All done. Is that clear? Are you getting it? Now simply solve this for molar conductivity at infinite dilution. Welcome back, Siddharth Chaudhary. How are you, dear? Okay, guys, so this will be how much? 25 square root of 25 is 5. Then this will be minus 2 minus 6 minus 4. This will be minus 2. Okay, square root of the whole will be 5 into 10 raised to the power minus 2. 19.6 lambda m infinity. On solving this, lambda m infinity value is coming around how much? Somewhat 3.92 into 10 raised to the power 2, guys. Or simply you can write it as 392. So, guys, the correct answer out of A, B, C, D is C. Done? Done. Is that clear? Well done. All those who are watching, if you have not solved this, please take a look at the screen, and if you could not understand it, please ask me in the chat box, ma'am, re-explain it, or I'll go ahead faster. Have a look at the screen. You have to simply relate the formula, put the value, given value. Okay, guys, and the best habit, best practice to solve a question is to jot down the things which are written, which are given in the question itself, there itself, and what is to be calculated. Automatically, you'll find that the formula is clicking to your brain. Okay, Soumya Swaroop Bishi, welcome to the class. Very good afternoon, Soumya Swaroop Bishi. How are you, dear? Soumya Swaroop, कैसे हैं आप? All those who are watching, do like the video, do share the video, and do solve the questions which is going to come on the screen now. Come on, you all guys have to solve this question. Do reply in the chat box by the time I'm solving it on the screen. Take your own time. By the time I'm solving it, try to solve this question before me, guys. Okay, Soumya Swaroop Bishi, fine. Soumya Swaroop Bishi is saying fine. Better solve the question. All you guys, Soumya Swaroop, all those who are watching, Siddharth, Hussain, Arpita, Swaranjali, Ritik, please, Mukesh, all you guys, Reena, all of you, please solve these questions now. Fatafat says solve the questions and do reply in the chat box. Guys, what is there? Conductivity of a saturated solution of barium sulfate is given. Guys, this is conductivity K. Done. Conductivity is given. Okay. Saturated solution of barium sulfate, conductivity is all done. Its equivalent conductance, guys. Equivalent conductance is this much. All done. Equivalent conductance is also given. And if conductivity of a saturated solution means Ksp, that means it is this value is given at infinite dilution, guys. Is that clear? Clear, guys? Done. Okay, so we have to calculate the what? We have to calculate what, guys? Yes, we have to calculate Ksp. All done. Simply putting the formula, guys, you know the formula. Lambda m infinity is related to, guys, conductivity. Yes, all clear, guys. Solubility. Directly write down the solubility over here. All done. I'm waiting for your answer, guys. I'm waiting for your answer in the chat box. Okay, guys, simply put on the value. Bring solubility over here. If solubility is calculated, guys, we can calculate this as well. All clear, all clear. Come on, all of you guys solve this and answer in the chat box. Answer aane laga hai. All of you please solve and do answer in the chat box. Guys, put the value over there. This is 3.06, 10 raised to the power minus 6. 1000, guys, upon this value is 1.53. All done, guys. This will get cancelled two times of this. All done. And the value will be coming around how much, guys? This will be 2 into 10 raised to the power minus 3. Then solubility is done. Guys, we have to calculate Ksp. Can we write this as all done? Done, guys. SNS KSP has to be, guys, S square. All done. Therefore, guys, KSP will be equal to 2 into 10 raised to the power minus 3 cos square, which is somewhat around this. But in the option 4 into 10 raised to the power minus 6 is not given. What is given because the value is so less, guys, 4 is ignored. And like in the answer, it is 4 into 10 raised to the power minus 6. Instead of that, it is simply 10 raised to the power minus 6 is given, and this is the nearest value to the answer we got. Therefore, D is the correct answer. Okay, all clear, Arpita, no worries. Please try next time. Aya samajh mein, did you get this? Have you understood it? So the best practice, I'm repeating again, to solve a numerical is to write down the things given in the question there itself. That will help you to click for the correct formula to be applied over there. And once the formula is correct, I mean click correct formula is clicked, you can simply put the values, given value over there and find out the value, guys. Solve that out. Simple. Okay, done. Let us go ahead. Soumya Swaroop Pishi. Haji, boliye beta. Do you want to say anything? Come on. Do reply in the chat box. Yes, guys. Now, all of you can see there is another question on the screen. You all guys have to solve this. By the time I'm solving it on the screen, you all guys solve it yourself and do reply in the chat box. I'll do the same way. I always do what? Okay, Soumya Bishi, do you want to say anything? Okay, no, done. Have a look at the screen. All you guys, please solve this question given on the screen and do reply in the chat box. I'm repeating again. Okay, guys, let me write down the things which are given. Molar conductance of 0.1 molar. This is the concentration, guys. Acetic acid is 7 per ohm per centimeter square per mole. This is molar conductance. Guys, at any concentration, we call this as molar conductance at particular concentration. All done. If molar conductance of acetic acid at infinite dilution, this is what, guys, this one is molar conductance at infinite dilution. All done. The value of dissociation constant will be, what will be the value of dissociation constant? Ka. We have to calculate the value of dissociation constant, guys. So simple question, isn't it? How come? Guys, you have the two value. So automatically if alpha is calculated, guys, we can calculate dissociation constant as well. Now alpha is, yes, molar concentration at any concentration, molar conductivity at any concentration upon molar conductivity at infinite dilution. Simply put that in the formula, guys. This will be 7 upon 380.8. All done, guys. Now using this, calculate alpha square. If alpha square is calculated, guys, dissociation constant will be simply C alpha square. All done. Guys, concentration given is 0.1 into alpha square is this 7 upon 380.8, guys, whole square. All done. Done, guys. Straight away going here or not? Is it straight away going here or not? Do let me know in the chat box faster. Done. What you have to do now, simply solve this will somewhat coming around this, guys. Done. So what is the correct answer over here? D is the correct answer, guys. Which is the correct answer? D is the answer, guys. All done. Clear? Is this clear? So what we did, guys, we studied today. We had studied today that there are 5 applications of Kohlrausch law. What's that? The first application is to find out alpha. Okay, find out alpha, guys. If alpha, that is degree of dissociation of a weak electrolyte, is known, we can calculate. The second application is what? Dissociation constant. Now guys, third application, which is actually first third कुछ भी बोल दो, 5 total है. Okay guys, the next application is what? To find out the molar conductivity of weak electrolyte at infinite dilution using molar conductivity of strong electrolyte at infinite dilution, which otherwise straight away we cannot calculate. Is that clear? Then the next one is to find out the solubility, and at infinite dilution, guys, solubility is almost equal to that of molarity, because feebly soluble salt, the solubility is too less. We can say that they are present, and actually the solution is infinitely dilute. Is that clear? And if solubility is known, Ks, we can straight away be calculated. Okay, guys, is that clear? Is that clear? All those who are watching, if you have not liked the video so far, do so. If you have not subscribe the channel so far, do so. If you have not shared the video so far, do so. If you have not pressed the bell icon so far, do so. And don't forget to apply this referral code of mine, S810, guys, and not only to have the discounted prices, but to have some additional help from my side, which you'll come to know later once you apply this referral code of mine. One more thing, guys, if all those who have not subscribed the channel, let's start NEET UG in English so far, do so. And don't forget to press the bell icon if you have not pressed the bell icon as well till now. Do so, guys. Do like the video. Bye, guys. All the very best for your studies, guys. Have a wonderful studies, guys.